This lesson is about AV blocks. Let's just do a quick review of the AV node. So here's the AV node. It has a couple of very important functions, one of which is it delays electrical impulses. When the SA node paces the heart, it delays the impulses from the atria to the ventricles in order to allow time for adequate ventricular refill. That way, when the atria contracts, there's a slight delay before the ventricles contract, so that the ventricles can fill up with blood and make for a more efficient pump. So that's ventricular refill. It also blocks rapid impulses, like we talked about with atrial fibrillation. If it wasn't for the AV node blocking a lot of those impulses when the patient's in AFib, a lot of those impulses would reach the ventricles, and anyone that went into atrial fibrillation would also go into ventricular fibrillation, which would be fatal. So the AV node is has a very important role in the electrical conduction system. However, it can also malfunction, causing some problems. For example, what happens when the AV node delays the electrical impulse for too long, or if it blocks impulses that it shouldn't block? So that's what we're going to talk about in the lesson of AV blocks. First degree AV block. First degree AV block is when the AV node blocks impulses delays impulses longer than it's supposed to. So a normal PR is 0.12 to 0.20 seconds. So if your PR, like if it's 0.2 to 0.20 seconds, that's normal. However, with first degree AV block, your PR is going to be greater than 0.20 seconds. So maybe this was your patient's PR measurement. Maybe it was 0.15 at the beginning of your shift, and now it's longer. So now maybe it's 0.25, something like that. So that's considered longer than expected, and that would be labeled a first degree AV block. Now you still have one AV conduction. There's still one P wave for every one QRS. Nothing's getting completely blocked. It's just your PR is longer than 0.20 seconds. The P waves are still expected to be upright, 1-to-1 ratio, and the QRSs are still relatively narrow. No change in the QRS because nothing's changing within the bundle branches. And that's first degree AV block. Here's an example. You can see here one large box like that. That's 0.20 seconds. So if the P wave, or the beginning of the P to the beginning of the QRS, is greater than one large box, then you know that it's a first degree AV block. And of course, we still have one P wave for every one QRS. And the PRs are consistent as well. You don't see fluctuating PRs generally with first degree AV block. The PR should be consistent, just longer than 0.20 seconds. Okay, so what happens if the AV node blocks out an impulse altogether? If the SA node paces the heart and the AV node blocks out one of those impulses, what's that going to look like? Well, if the AV node delays those impulses gradually and that PR gets longer, then we call that second degree AV block type 1. And what's that look like? Well, you get this progressive lengthening of the PR until one is completely blocked. And then the PR resets itself. So You can see how the PR gets longer and longer until that impulse is completely blocked through the AV node. We call that secondary type 1. It's also called Winky-Bach, also called Mobitz 1. So what are the manifestations of this? Well, where the block is present, here where there's a blocked QRS, that's going to be irregular. The R to Rs are going to be irregular. The PR gets longer, and the P waves are still expected to be upright. However, there's at least a 2-to-1 AV conduction with this. So you've got 2 P waves here and here for every 1 QRS. Now here is an example of second-degree AV block type 1. You can see how the PR gets longer, and then one of those electrical impulses is completely blocked, and then the PR resets itself. Also, you can see the R to Rs are not regular. Second-degree AV block type 2, also called Mobitz 2, is a little bit different. In second-degree type 2, you still have the SA nodes pacing the heart, and one of those electrical impulses gets blocked. However, there is no lengthening. The PR remains constant in second-degree type 2. So your PR stays the same. The whole time. So there is no lengthening of the PR in second-degree type 2. P waves are still upright. There is a 2-to-1 AV conduction, just like with second-degree type 1. But the PR remains the same, and the QRS is relatively narrow. Now, second-degree type 2 is more serious than second-degree type 1. Secondary type 1, it can be a result of normal physiological processes where the AV node is increasingly delaying that impulse until it gets blocked. But it can reverse itself. It can go back to normal. Now, second-degree type 2 is considered to be more severe because it's more likely to be a hardwiring issue with the pacemaker electrical conduction system. Okay, here's an example of second-degree type 2. You can see these PRs don't change. They're the same. And then one of those electrical impulses is completely blocked, and the PRs are the same. Okay, so what happens if all the electrical conduction system, all the electrical impulses through the AV node are blocked? So the SA node is pacing the heart, right? Producing P waves, but if everything through the AV node is completely blocked, what's going to happen if nothing gets through? Well, you just have P waves, wouldn't you? Like that. No QRS complexes. This is called ventricular standstill, where there's no R to R interval. The atrial rate, well, it's whatever the SA node is pacing at. Ventricular rate is 0 because the ventricles aren't pacing at all. Of course, there's no PR because there's no QRS. P waves expected to be upright and no QRS. So since there is no QRS, and the QRS represents ventricular depolarization and therefore contraction, you have no heartbeat. So this would be fatal if this persisted. However, we did talk about redundancy in the heart. So your heart has redundancy. So if you do go into this ventricular standstill rhythm, where you only have P waves and no QRS complexes, so your heart rate is 0, then the AV, or the bundle of His, can potentially pace the heart. And we would call that third degree AV block with a junctional escape rhythm. When the bundle of His paces the heart, it depolarizes your ventricles at a rate of 40 to 60 beats per minute. That's what's expected. However, there is no electrical conduction through the AV node. It's completely closed down. Now, the SA node is still pacing, which produces P waves like this. But completely independently of that is the bundle of His pacing the heart. So what you have is you have this junctional rhythm that's slow, that is pacing completely independently of the atria. So you get AV dissociation. So there's no PR interval with this. You have two rhythms that are pacing completely independently of one another. And you still have upright P waves. QRS is relatively narrow because when it occurs from above that fork, it travels down both sides of the ventricles at the same time, and it produces a rapid and even depolarization. Now, this could be a very confusing rhythm for people because it's hard to separate the two rhythms in your mind. You have atrial rate up here of 75 beats per minute, but none of those impulses are reaching the ventricles. So the ventricles are forced to pace on their own, paced by, in this case here, the bundle of His is pacing the heart at a rate of 43 beats per minute. So two very different rates. The ventricular rate is going to be slower, and they're pacing independently of one another. Now, you can't see this on an ECG strip. What you see on the ECG strip is what you see on the very bottom here, where you've got, it looks like there's a P wave there, and a P wave down there. There's a P wave there, and there, and there, and so on. And it's superimposed over this junctional escape rhythm. And a lot of people get this confused with second degree AV block type 1, because in second degree type 1, you have lengthening PR intervals. So what some people do is they look at this PR and they'll look at this and they'll say, well, it's getting longer, so therefore it must be second degree type 1. However, one of the defining characteristics of second degree type 1 is that where there's a block present, the R to Rs are irregular. So that's really the defining characteristic between understanding third degree AV block with a junctional escape rhythm and second degree type 1 is if you have a third degree present, then your R to Rs are going to be perfectly regular. You would expect them to be. However, with second degree type 1, where that block is present, you're going to have irregular R to Rs. And here's an example of third degree AV block with a junctional escape rhythm. You can see the R to Rs are perfectly regular. And there's a P wave there, and here, and here, and here, one hidden in there. one there, one at the end of that T wave. So there are two rhythms that are superimposed over one another. Okay, so now with third degree AV block, you can also have a ventricular escape rhythm. Now this is when there is no impulse, there are no impulses coming from above the ventricles. This is somewhere within this conduction system down here, the ventricles are pacing the heart. And when you have the ventricles pacing the heart, you have a very wide QRS complex. Because it's not like they're traveling, these impulses are traveling down both sides of the bundle branches simultaneously. Instead, it's starting at one side or the other, and it's working its way across the ventricles, and it takes longer. So when it takes longer, you have a wider complex. So in this scenario, we have AV block, so no impulses are getting through. The SA node is still pacing the heart, but none of those impulses are reaching the ventricles. So you have, like I said before, you've got, this is your atrial rhythm, and then pacing completely independently of that are the ventricles. And you have this really wide, kind of bizarre complex that's pacing very slowly at a rate between 20 and 40 beats per minute, because that's what idioventricular rhythm is expected to pace, is between 20 and 40 beats per minute. Here's an example of third degree AV block with a ventricular escape rhythm. You've got P waves that are, some are hidden, and one there, so there's going to be one in here somewhere. There's one up there and one there, one on that T wave. So you can see the atrial rhythm is going to be regular. You can see each P wave maps out. However, the QRS complexes are also regular. And like we said before, if the R to Rs are perfectly regular, like this, and you have this variable PR, then you'd want to consider third degree AV block. Third degree AV block, you're going to have the atria pacing completely independently of the ventricles. So there really is no PR, it's just dissociated.